whether you're still clapping at the end of the talk. So I wanted to talk to you about how we've been using MongoDB over the last few months at eHarmony, and some of the trials and really solutions that we've come up with over that period, bringing what was kind of an incubator project that we had into full production and running it at scale for some months. Before I get started, how many people here are using MongoDB in production right now? Okay, a few people, maybe 20% of the audience. Okay, so I'm going to be talking about 5 high-level lessons over the course of the next 30-40 minutes. I think I'll be talking, and then we'll have time for plenty of questions at the end. So first I want to give you an overview of the application context in which we use MongoDB. So most internet dating sites work a lot like any other kind of search-based service online, and finding someone that you want to date is a lot like acquiring something on Amazon or picking a restaurant on Yelp. You type in some search criteria and you see some profiles, you look at the pictures and you decide who you like. At eHarmony, it's a little bit different. First of all, each one of the products that you're looking at has to like you back. They have their own criteria, and you're both customers of ours, and we really want both of you to be happy. But that's really only the first of 3 major portions of how we do matching. So first of all, if you only want to date Jewish vegetarians, you can do that, or any number of different criteria: drinking, smoking, race, religion, whatever you want to search on. That's kind of step 1. Second step is compatibility models based on psychological research conducted over many years by people who actually have PhDs in psychology and work for major universities. And that's what you see on the TV commercials when it says 29 dimensions of compatibility or what have you. The third part is the machine-learned affinity models. We're very active in the machine learning meetup. If any of you have been to those, a lot of those are held at our campus. And that's really complementary to the compatibility models. The compatibility models tell you, if you were to get married to this person, would you have a great relationship? And the machine-learned models tell you, are you even going to be interested in talking with this person? If you would be in a great relationship 20 years from now, that's kind of moot if you see someone's picture and their hair is kind of weird and you're not really that interested in talking with them. So the affinity models predict for us, based on the observations we make of users on the site, what class of users is likely to want to communicate with which other classes of users under what conditions. And then we try to create those conditions and meet up those users together. But what we're going to be talking about tonight in the rest of this talk is kind of the first half of this. The family of applications where we use MongoDB is about creating a set of potential matches for each person on the site. Other people that could be given to them as matches if the conditions are right in the matching pool at a particular point in time. So we're looking at, as quickly as possible, querying the set of user data that we have in MongoDB to find people that match each other's preferences, and then we run that smaller set through compatibility models to weed out people who might match the level of drinking or smoking or age or location, but might not be a good relationship fit for you. And then that forms our personalized matching pool for each one of our customers. So that's a Java application that runs on top of Mongo. Mongo is used to store all of the user data that feeds that application. It is a replicated and sharded cluster, and the data access patterns are heavily tilted towards reading. We do have writes that are going on all the time to keep Mongo up to date with the state of the world and with the state of the users that are in the pool. But really, the vast majority is reads. Each particular request or event that we're processing could lead to multiple reads, and each read could have a dozen or more different filtering criteria on it. So it's pretty heavy-duty reading. So that's going to be the context for some of the tips that I'm going to be giving you. If your pattern of usage of Mongo is different, then take what I'm saying with a grain of salt. I'll try to call out some of those things because the way that you're going to want to configure your cluster can be different depending on whether you expect to be read or write heavy or an even combination of the two. So we've had this configuration in production for more than 6 months now, I would say. We rolled it out gradually. The first thing we did is we had it in kind of a shadow mode where we had live production data going through, and we had a backup copy of the application running, and we could measure the old version of our application and the new MongoDB version of the application against one another and use that to tune our configuration. And then we rolled out into production, and since we've done that, we haven't had any outages. And the greatest thing as an application developer that I can say is that I no longer have to worry that much about MongoDB, which is great because for me it's plumbing, and at this point it's working well, and so that's great. I'm very happy. So this leads me to the yes, sir.
So when you said you had part of the production traffic go through that other application, are you talking about you were capturing the transactions and doing them against the other application through a tool, or were you just redirecting part of the traffic to that version of the application?
That's a great question, and I have a section of the presentation coming up that will address that exactly. So the first thing that I want to talk about is how to provision the cluster. The most basic thing, and probably if you've been reading tips online, you've seen this already, MongoDB is based on memory mapped files. What that means is if the working set of your data plus your indexes on any given box is larger than the amount of physical memory you have, it's going to start swapping and your performance is going to become significantly less. So what this means, for example, is if you've tested with some small data set and you've got great performance and you're really happy, and suddenly you dump 4 times more data in because you're ramping up towards production, don't be surprised if bad things happen. So you want to plan for that ahead of time. Also, I know a lot of people use Mongo in virtualized environments. They host it on Amazon or something. So especially if you're using VMs, be aware that, make sure that you've provisioned the VMs with enough memory, and that the memory that your VM claims that it has is actually going to be, with high probability loaded into physical memory on the box that the VM is running on, or your performance may change a lot. And one of the things that helps you with this is keep an eye on your schema. MongoDB prides itself on being schemaless, very low administration. You just dump JSON documents in there. The way I like to look at that is, since the database doesn't have a schema, what that really means is your schema is repeated with every single record in your database. Because although the evolvability is great, I may run my system for 6 months and then decide I need to add an extra field. I've got another 100 fields in there that haven't changed and that are the same for every record. So you may easily find that half or 3/4 or more of the data that you're storing is actually the names of the fields in your data structure. So what we've done is, in the serialized version of our data, every field is just a 1 or 2 character name, which is not really awesome for debuggability, but it provides us a little lookup key that we can look in the master record. You can use Morphia to help you with this. It's the object mapping library that works with MongoDB, and you can use annotations on your data type so that your code can have nice long descriptive names, and then you can say, and when this goes into the data store, it's just A. It helps a lot. So keep that in mind. So that's the starting point. That's one box. And now let's talk about how you move from the one box up to a complete cluster. So this is kind of a generalized picture of a MongoDB cluster. You have some number of shards. Each shard is a replica set. Each one has a primary node and some number of secondary nodes. So how do you think about how to divide up your available hardware? The way I like to think about it is, first of all, your data volume and your write operations are going to be scaled by adding more shards to your cluster, because your writes are going to go to your primaries. So the more primaries you have, the more write throughput you can do. And furthermore, because the amount of data that you can store on any given box is really limited by the amount of physical memory on that box, which is going to be relatively expensive part of the configuration of that box, you can add more shards in order to increase the total size of the data set that you can keep in memory in your cluster. On the other hand, if you're satisfied with eventual consistency, you can configure MongoDB to do your reads preferentially from your secondary replicas. That means that you can scale your read operations by adding more replicas to each replica set. So if I have, three secondary or three nodes in a given replica set, I can do reads off of all of them concurrently. If I have 5, if I have 7, I can do more reads yet. There are actually some cases when your read operations can also scale with the number of shards, and I'll talk about coming up with a good shard key later on in the talk. But this picture kind of leads me into the second lesson that I have for you today, which is be ready to kind of tweak things and experiment and try out a lot of stuff, because Mongo has a ton of moving parts. For a good sized cluster, it would not be unusual for you to have maybe almost 20 processes that you have to administer, because you have an instance of MongoD on each node. You have, if you're using Mongo Monitoring Service, MMS, which I would highly recommend that you do, you're going to have an agent or two for that. If you have a sharded cluster, you're going to have at least one, but possibly as many as one instance per instance of your horizontal application of the Mongo S process, which is kind of the facade for the sharded cluster and directs queries to the appropriate shards. You're also going to have 3 instances of the config server, which controls which, or keeps track of which chunks which chunks are located in which shard. It's a lot to keep track of, and each one is configured separately. It has a local configuration file that has to contain the right options for it. But in addition, when you're adding boxes to your cluster, when you say, I want to add a secondary to this replica set, you can't just put that in a configuration file. You have to issue commands through the Mongo shell or through a driver in order to do that. So there's still a lot of manual setup on top of that. And depending on the DBA support that you have in your company, you may or may not have good ops support for this. More of the work may be pushed onto your application team. So be ready to deal with some of those yourself as application developers, and be aware that some of your best practices that you may have been familiar with from a relational world may transfer over, and some may not be exactly the same. So the first thing that I would say as a practical step to mitigate against all the stuff on the left is use some kind of a configuration management system like Chef or like Puppet or something else that can help you keep all of your config files in a consistent state across all these different boxes, because there's going to be some stuff that can only be done through a MongoD. There's going to be some stuff that can only be done through a Mongo S. Some of the MongoD stuff can be done through any MongoD. Some can be done only through the primary. Some commands could be issued to a MongoD or a Mongo S, but they'll have different effects depending on where you issue them. So if you're doing all this ad hoc and trying to upload files and type in commands all by hand, you're going to break something sooner or later, and probably sooner, because I've done it, and you don't want to be in that situation. So a configuration management system can help you with getting all of your config files in the right places. It can't by itself help you with all the kind of manual scripted things. So you're going to want to have some scripts that will run automatically when you do a configuration deploy to make sure that the right nodes are in the right replica sets so that they get the right data on them. You're going to be tempted, or at least I was tempted when coming onto this task, to use the Mongo shell for this. You're going to see documentation that says you can just write a JavaScript file and you can pass the script off to the Mongo client and it'll execute the script for you, and you're going to think that's going to be so easy. It's not easy. the output of some commands is like text that goes to the terminal. Some comes back as like return values that you can capture in a variable. Some things you issue the command and it takes a while to execute that command, and you can't block in JavaScript. So just treat it as an administrative application. Use a real driver library rather than the Mongo shell. They provide a Python driver that you could do this if you want to think of it more as a scripting, or you could, if you're writing your code in Java, you could just write this as a separate Java application and use the same driver that you're using for your app. However you want to do it, just take this task seriously at the beginning so that it doesn't come back and bite you later. And, you know, as an app team, you're probably still going to have to be involved in this, but the more that you can train up your DBAs to help you, if you have a DBA team, that's going to be awesome. At least, you know, from my experience, people are really excited to learn this stuff. They want to be up on what the cool new technology is. So if you work with the other people in your organization, I think you're going to have a really good experience. So the next thing that I want to talk about is what I mentioned before and what you alluded to in your question, is what we called shadow mode when we were doing it. And what we did is we had a prior version of our applications using a different database technology, and they were receiving live traffic from the site. They were also receiving some back-end events that we generate. But we had those same events also forwarded to another event stream that was going to our shadow Mongo cluster, where we had separate instances of the application, separate copies of the data, and then we were able to benchmark both of these systems, not only in terms of the data store level performance, but also the business level metrics, and really compare them. What kind of business relevant throughput are we getting on this cluster versus this cluster, and why? And that was just an enormous help in doing things like figuring out what are the right indexes to have, what's the right way to shard the data, you know, are the even low level stuff like, are the boxes behaving well, are the networks configured correctly? It was very helpful. I plugged MMS before. It's really great at giving you kind of the low level stats. It'll tell you how many IOPS you've got, but it's really insufficient for measuring a real business application. You're going to want to have some custom monitoring that measures at the granularity that you care about. For us, we use Graphite for storing that stuff, which is free, pretty easy to set up, but you may have your own thing that you like to do. And while you're testing that, it wouldn't hurt to just periodically knock over a process or two, see what your application does, because after all, it's in shadow mode. It's receiving real input, but the output, you know, should be blocked off in some way so that it's not going to have any downstream effect. So let it crash. If the Mongo S goes down, is your application going to recover when it comes back up? Are you going to lose whatever requests happened in the middle or not? So just be aware, because sooner or later, maybe it'll happen to you. And that's my next lesson. Sooner or later, for whatever reason, you are going to be in a situation where you're going to look at your Mongo cluster and you're going to say, I don't want any of the data that I have in there anymore. And there could be a variety of reasons for that. Maybe you're just hearing this advice about keeping your field names small for the first time today, and you just realized that your cluster is about to fall off a performance cliff based on the amount of data, and so you want to change the schema of every single field, every single record in your database. Or maybe you've decided that you've got this thing in production and it's working pretty well, but it's not performing very well because the data is not sharded in an efficient way. And you can't change your shard key on a live database. You have to copy it somewhere else. Maybe you'll even experience MongoDB bugs. One of the great things about data stores like MongoDB is they evolve very quickly. They provide new solutions all the time. The downside of that is it's new technology. It's a small team, although they're worth a lot more money than I am at this point, so maybe that will change. But you will experience issues with the software from time to time. That's just reality. So what I would say, first of all, is make sure you have another copy of your data somewhere in a different format. And maybe that's a secondary Mongo cluster that's on a significantly different version that's not getting the same traffic that your real data is. Maybe it's a backup in the file system. Maybe it's a relational store. But some other format that you can use to pull the data in. The convention that we've adopted, which has worked pretty well, since you can't rename databases in MongoDB in a live system, what we do is we just have a suffix on the name of the database, and each time we do a reload, we increment that suffix. So what we can do is we can be serving live traffic from our Mongo cluster with a certain set of databases and collections, and meanwhile be sideloading the new copy. So then once the new copy is loaded, we just change a configuration that says hit that database instead of this database, and everything switches over, and we don't really have downtime. That's worked out pretty well, and we've done a few reloads that way and haven't really had issues with it. The last point here is once you have this system, once you have your really nice backup, and you're convinced that the backup is solid, and you have a way to sideload that backup without having downtime in your application, just practice it. Don't say, well, this is here for disaster, and let's pray that the disaster never happens. Assume that the disaster happens tomorrow morning at like 10:30 when everyone's in the office and has had their coffee, and just pretend that you need your database to be refreshed, and just do it and get a sense for how long it's going to take you and what the problems are. Yeah.
So what do you guys use for backing up data? Using just Mongo dump or?
We have a relational store that's our ultimate source of truth, and so MongoDB is in between that and the application as a way to facilitate search of denormalized objects and take the load off of our Oracle database. So for us, we're not that concerned about backups because our backup is our relational data store, and so we have the ability to reload from that.
And what you were talking about is you're preparing for a schema change.
Right, a schema change or a sharding change, or there are cases where we've gotten a call from the MongoDB folks saying we're very sorry, but there's a critical bug in the driver, and under these edge conditions, you may have had corrupted data, and we don't know whether any data is corrupted or not, but we have the ability to restore in a short amount of time, so we just do it. Then we don't have to worry about it. Yeah, another question in the back.
I'm kind of confused. When you do the increment DB name with each reload, and suppose that works, and so now do you have two copies of the data, which are under different names?
Yes, we do.
And
we're only using one at a time, so we're using one, we're sideloading the other one, then we switch over to use the second one, and once we're on the second one, then we drop the first one.
When you say drop, you mean actually delete it?
Delete it.
Okay.
Yep.
It's funny because Solar under the hood does very similar things when they index, right? They index complete different index in the directory. As soon as that index is updated, they close the original index, open up the new index, and drop the other one.
Right, because otherwise you need to keep a lot of metadata around about what you've visited and so on, and it's just a headache. It's easier just to create new and throw away the old. So I brought up shard keys here. Sharding is kind of, depending on your data access patterns and how heavy you're going to hit your Mongo cluster, it's kind of a black art. So it's good to have your ducks in a row before you go down that road. And getting back to the previous slide, put yourself in a situation where you can be confident that if you want to change the way that you're sharding, that you don't need to get into a lot of really heavy data migration problems. Just reload your data, throw away the old data, and move forward on that path. Because once you pick a shard key for a given data set, you can't change it. You're going to need to reload the data if you want to change it. So there's three things that you want to look at and think about when you're sharding data. First of all, you want the data to be sharded such that the volume of data is equivalent across all your shards. Obviously, that's actually what the auto balancer inside MongoDB does for you automatically. So you don't really need to think about that. The other two you do need to think about. The second one is if you are read heavy in your application, think about how your shard key can help you isolate queries to a subset of your shards. Because if you know that you're sharding on fields that appear in many of your queries, there's a high probability that any given query will only have to run against one or two shards rather than all your shards. So that means as you're scaling out the number of shards, you're also scaling your read performance in addition to your data capacity and your write performance, because the nodes in one shard can be fulfilling one read while the nodes in another shard are fulfilling another read. That's very helpful. Finally, you want to be aware of how the workload is distributed across your cluster, especially in the presence of the first two items. And these are kind of in conflict. And one way to think about this, suppose I have a cluster here, and suppose I represent an internet dating site and I have user data in these. If all of the hot people are in one shard and all of the nerds like me are in another shard, the interest among the users of the service in these two cadres of people are going to be different. And that shard is going to get a whole lot more queries than this shard. And the machines over there are going to start heating up a little more than the other machines. So depending on how you want to configure things, that may or may not be a problem for you. If you're doing a write-heavy application, you don't have a lot of reads, maybe you don't really care about that. But maybe you do. So here's some specific tips. First of all, if you are concerned about read volumes, you want to be able to isolate your queries to particular shards. So look at sharding based on fields that you have in every query, if you do indeed have fields in common like that. And look for a combination that will pretty finely partition your data, so that based on the shard key alone, Mongo is going to be able to do a lot of work for you on your behalf and execute your query very efficiently. And while you do that, take a look at the relative load across your shards. It's very common to think in terms of all the shards being identical to each other. They actually don't have to be. You can have more nodes in one replica set than you have in another replica set. So, for example, if you're doing reads off of your secondaries and one shard is getting more traffic than another shard, just put more secondaries in that first shard. If you're running three nodes, go to 5 in that one, or go to 7 in that one. It may look kind of crooked when you're drawing your architectural diagram, but who cares? There are also certain things that you're going to want to beware of when you're choosing your shard key. If you're like us and you have a relational store where you're also keeping your data, you may have records that are identified by like sequence numbers incremented by your relational database, and you may be tempted to just say, well, I'm just going to divide people based on their IDs that are generated by my database because I know they're unique and I know that they're kind of arbitrarily assigned to users. What's going to happen, though, when you do that is all of your new records that are inserted are all going to have consecutive IDs, and they're going to go into Mongo, and they're all going to hit one chunk. So what's going to happen is all of your new data is all going to end up in the same place, and then the rebalancer is going to be working super hard in the background to shuttle that stuff, and your chunks of data are going to get split and shuffled and split and shuffled, and the performance on your cluster is not going to be what you want it to be because there's going to be all this background activity, and you're going to have super high write loads all in one place.
There's probably other good reasons not to sequence your cust IDs as well. We were doing similar things, so you couldn't guess the cust ID based on yours because the next one over could have a complete different range of digits.
Right. Absolutely. Yeah, for security and other reasons, it's also good to avoid that. So the next thing that I wanted to talk about is hashing. I believe in the current version of Mongo, the the default way, when you set up a sharded cluster, if you don't say what hash key you want to use, it'll use a hash of your object ID. Hashing is nice if you're doing a lot of writes and not a lot of reads, because in addition to being really easy, it means that your records are going to tend to naturally be scattered around your cluster, irrespective of whatever their business relevant attributes are, which means that kind of load clustering problem that I brought up, where some shards get hit a lot harder than others, is not going to happen so much for you, which is a good thing. On the other hand, if you're read heavy, hashing is going to be an issue for you potentially, because what it means is whenever you issue a query, Mongo is not going to know which shard that query is going to hit, so it's going to have to hit all of your shards with the same query in parallel, and then assemble the results back again on the client side, or at the Mongo S. So it's going to increase the load on your cluster and increase the overhead somewhat in getting your query results back. So depending on your workload, consider hashing appropriately. Also, another thing to think about is MongoDB assumes that all of the fields that you use in your shard key are immutable, which is a perfectly reasonable assumption on their part. One thing that I'm going to encourage you to think about is not only whether the fields are mutable or immutable in fact, but whether they're immutable in practice, because as engineers we try to imagine that the world runs in an orderly way. And for example, you might have, say you're Craigslist and you're helping people buy cars, and because everyone searches for cars based on the model year of the car, you're going to put that model year in your shard key, which seems perfectly reasonable to do, except that when you realize that when that crowdsourced data is coming from millions of people, lots and lots of people are going to put their car in the database with the wrong model year on it because they screwed up. And then they're going to call your customer support and say, oh, that thing that I put in there that I said was like a 67 model year, it's actually a 69. I totally forgot. I got it from my brother-in-law, blah, blah, blah. And you're going to have to change it. And what can happen is if these immutable fields actually do change and you do an insert with the new data, it may overwrite the data that you had there before, or you may end up with additional copies of your unique records. And the uniqueness of your object IDs, Mongo doesn't necessarily enforce that across shards. So you can end up with the same record duplicated in each shard. And so both of those records, or all of those records, are going to be in the indexes. They can all be picked up by your queries. So someone looks for a 67 car and they get that car. Someone else searches for a 69 car. They get the same car with the year different, and it's going to cause headaches for you. So if you do find that that there is any situation, even an administrative situation, in which your shard fields can change, you're going to have to implement that at the application logic to make sure that you do a remove and add and double check for race conditions after, and you're going to need to just build that in. It's extra work for you. If you're not doing a lot of reads and you want to just hash on object ID and deal with query overhead and not do a custom shard key, then you don't need to worry about any of that stuff. But if you are read heavy and you want to really optimize those reads, then you're going to want to be really aware of this stuff. So that's what I have. Those are the 5 high-level points. Be ready to provision appropriately. Be ready to tinker with that cluster once you have it up. Keep tinkering even as stuff is starting to receive production data. Measure everything. And if something goes wrong, or even you decide that you want to configure something differently, just don't be afraid to throw it away and start again. The more you do that, the easier it'll be, and you won't even think twice about it. And then finally, the lowest level thing here on the list is if you're sharding, that's probably an area where you want to spend a lot of attention. That's all I have. Thank you. Questions, comments? Yeah.
So are you guys running on VMs, your own VMs, someone else's VMs?
We're hosting it in our own data center, and we're running on hardware.
So Iron.
Yeah.
So how's that working out for you guys? Better, worse? Because I know some people, different philosophies always.
Right. It works out pretty well for us. In the past, we have used VMs for some things. The team that I'm on the matching team. We're a back-end team. We drive a lot of load through our own systems, and we kind of know what that load is and when it's coming. And so for us, having something that's going to behave in a predictable way with high performance is more important than having a huge amount of elasticity. So for us, having hardware resources that we control is a good buy. Yes, sir.
I'm relatively new to this, so I wonder if you could essentially, since you have a backup as a relational database,
Mm-hmm.
what's the argument for not running the thing in the relational database in the first place? What advantage do you get by going to Mongo?
Sure. So there was a time in the distant past where we did run all of our applications directly against that relational store. We use a lot of different metadata about a user in order to make the decisions that these applications make. And so to pull that all out of the relational store, it involves doing a lot of joins, and it involves doing a lot of queries in a short period of time. And so it gets to be pretty expensive, both for the application to get that out of the relational store, as well as impacting the performance of the database for other applications that need to use it. So for us, MongoDB is nice because it's very natural to store denormalized objects in there, and yet, although the objects are denormalized, you can still run searches against them. So it's a good balance, and so it's a natural kind of search store or caching store for us. Solar is another thing that we looked at in the past. Yeah.
Are you writing to the relational store first, or are you writing to it simultaneously when you write to Mongo?
We write to the relational store first, and then we send some events that we use to keep the Mongo up to date. Yeah, over here.
In one of the slides you mentioned you can have sort of an unbalanced charts.
Mm-hmm.
Like, if the load is low, you said like not have any replicas that like have any secondaries on a particular shard.
I would say it's probably best to have some number of replicas on each shard, but you can have more replicas on one shard than another. So you want to have an odd number of nodes in any replica set so that they can handle primary elections properly. So you probably want to have a minimum of 3 in each replica set, but if you wanted to go to 5 or 7 in one that's particularly hot, you could do that.
Have you looked at HANA?
No, at least I haven't. What is that?
The in-memory processing, in-memory database.
Okay, no, I'm not familiar with it. Yeah.
I don't know if you could talk about that mechanism you used for shadowing the application. Did you guys have like a load balancer, or was it a custom?
We were sending in traffic through JMS, so we just had a topic that would relay across live and production, and then we just had it set up so that the outputs of the shadow would not be consumed by anyone else.
You can just go to the switch and set a mirror on those reports. Yeah, so.
Yeah, question over here.
Small notice. Somewhere at the beginning we said that it's almost necessary for MongoDB to keep all the data in memory and indexes. But there's actually a difference between all the data and, let's say, a working set.
Correct.
So, for example, for all the data, it's usually sometimes like probably almost impossible to fit everything into memory set, right? Because it could be a terabytes of data. But the working set is a little bit different concept, right?
Sure.
Usually, sometimes you can work towards and optimize it to actually fit into the memory.
That's right, and that's a good point. If you have particular data that is only very rarely accessed, and you want to still keep that in Mongo, but it won't fit in main memory, that's fine. It will work perfectly well. Just be aware that you're going to pay the price to get that off a disk. Yeah, absolutely. Yeah.
In terms of like the schema stuff, I noticed as I was looking at different people's names, holy crap, some of these could take up a lot of space if I pick a maximum. Some of the Indian coworkers I have is. What do you do with that? What do you do with data like that?
If it's first of all, actually the data that we keep in Mongo is kind of sanitized. So things that are personally identifiable information that are not really relevant for the particular matchmaking task that we're doing are not in Mongo. So,
okay, so you'd like put in a hash for the guy's name?
we don't need the name in Mongo at all. So we have full data in our relational store, but since Mongo is just used for searching, I mean, unless we had a feature that was like, I only want to date people named Tom or something, we don't need to have that information in. But your more general point is, yes, sometimes your data is big and sometimes it's encoded in an inefficient way. And to me, that's fine because that's the application data. But when you're talking about the names of fields, like every time I have the name Tom, I also have to have an identifier that says first name colon quotes, Tom. I mean, quotes aren't there. It's BSON, not JSON. But you have overhead that comes from the way that the data store functions, and that overhead can be significant if you don't plan for it. Yeah.
What do you guys do full text search? Against Mongo?
Against Mongo, not at this time.
What do you guys use?
We've done some text-based analytics that we host in a different service using some other open source products, but we don't. It's not in this application. Yeah, you had a question.
Yeah, okay, so let's say you've come up with a new scenario for matching people, and you want to implement that. Can you step us through the rollout? Because I presume you're going to start with a change in the relational database and then cascade it down to your Mongo.
Well, the most frequent change that we make with respect to how we match people actually comes downstream from this application. So I remember at the beginning I drew up 3 boxes of, first of all, we create a kind of a personalized candidate pool of people based on your respective selection criteria, things like age, race, ethnicity, gender preference, those kinds of things. And then that flows through compatibility models, and then that flows through affinity models. So the most rapid changes that we make have to do with the affinity models. Actually, it's right. So they don't actually impact the generation of this personalized candidate pool. They have more to do with spotting correlations in the behavior of users. People of this age who live in places like this are more or less likely to want to communicate with people like that who live in other places. So those don't actually require any data changes. Those are just purely algorithmic. If we wanted to, for example, start gathering a new set of data about our customers, maybe we had not let people search based on smoking before, and now we were going to add that for the first time. Yeah, we would add that at the source of truth first, and then we would add that to Mongo. And that type of incremental change to a schema is actually very easy in Mongo, because you can just start including that new field in your record. The existing records that are already in there won't have that field in it, so you'll have to deal with that at the application. You may issue a query and get some data back that doesn't have that new field that you added. But barring that, it's pretty transparent. You don't need to think about reloading or anything like that. Schema changes that would make you want to think about a reload would be more wholesale changes. Maybe you had kept some particular state in like a nested object and now you want to flatten it out, or vice versa. Something like that, would break a lot of your queries because you would be referring to fields in the wrong way. And so rather than having to query for the same thing 2 different ways and maintain that in your application, it would be easier for you to just reload the data with that new schema. You had a question over here.
Are your reads distributed through time, or is it like a big matching event where all the read activity happens? I mean, are you doing sort of incremental matching as data changes? Or?
Yeah, it's distributed throughout the day. It's 24 hours. I mean, we have certain load that is organic from activity on the site, which operates around the world, and then we have other data that is from automated processes that's also continual. So, yeah, and in the back there.
What's the size of the data you're running on Mongo, and how does that compare to your relational database? And then a second question is, you mentioned names as one field that you would have on Mongo, or you wouldn't have on Mongo, but have in a relational. But otherwise, I would assume it would be a question of archiving according to time, right? Is that you have older stuff in the relational versus in current in the Mongo, or are there more fields worth mentioning that you don't keep that you don't?
So it's
for Mongo queries?
Yeah. So the data that we have in Mongo is a subset of the full data set that we have, and it's really the subset that we need in order to facilitate searches in this one particular family of applications. So there's a lot more in our truth data store that is not relevant to those applications or is not relevant to that particular task. So we don't bother to keep that in Mongo. That's one of the nice things about kind of keeping this dual data management kind of solution, where you have the data that needs to be in Mongo, but you have the ability to refresh Mongo if you need to, rather than using it as the absolute source of truth. In terms of time correlation, there is some, but it's not very strict. Correlation, but not causation. Let me put it that way. Yeah.
Can you say how many unique users you have a day?
No, I probably shouldn't get into that.
The reason I ask is because as Obamacare was having problems.
Yeah, it's Windows 2003.
And I heard them say that it was designed for 50,000 people a day. And as an engineer, I roughed out some numbers and said, your average day is probably going to be 5 times that. So, well, no, yeah. 5 times that. And so I just wondered if, I was just curious to compare their hits versus yours, that's all.
Mm-hmm. Yeah, I mean, our load on Mongo is not, it's correlated with activity on the front end of the site and user visits and so on, but there's a lot of other factors that go into determining how hard this cluster is going to get hit.
Can you speak to how many shards you have and how much data?
I probably shouldn't get into like specific data volumes, but we have single-digit number of shards. That's probably pretty broad, but any other questions? Yeah.
How much memory do you have to put into the
It really depends on how many shards you want. If you could have all of your data in one replica set, or you could have 2 shards, and then you would want to provision the memory on those machines pretty beefily if you have a large working set. If you want to get a lot of write throughput across different primaries, then you may decide to have a relatively large number of shards and just not store very much data on each one. Maybe you only want to store a few gigabytes of data on each box because you want to really scale it out really wide horizontally so that you can get a ton of write-ops through there. On the other hand, if you want to use the hardware that you have maximally efficiently in terms of the memory and the storage that you have provisioned on there, and you're not that worried about the throughput of operations, maybe you just want to have a smaller number of boxes and put, a couple hundred gigs of memory on there and just store a ton of data on those. It depends on the pattern of usage that you have. What else? Yeah.
What database did you have before, and why did you change?
Previously, we were using another relational database, so we kind of went through this incrementally. We had our kind of base level source of truth database, and the first generation of these applications hit that directly. Then we found out that was it was not having the performance that we wanted, so we added kind of a second relational tier of data, still relational on top of that, but distributed in a custom way. And what we found was keeping those separate kind of manually distributed relational copies in sync, not only with the source of truth, but also with each other, just proved to be a lot of overhead and a lot of just kind of it was kind of error prone. So we started looking for something that would be a centralized source of data in that kind of middle tier, and it would have some natural scaling built into it so that we wouldn't have to do that replication and sharding ourselves manually. And that's how we came to MongoDB. Yeah?
Were there other NoSQL products that you looked at, and if so, then what made Mongo stand out?
That decision was before my time, so I can't really speak to the details of it. Solar was the other major contender there. My understanding was that two of the things that made us go with MongoDB was it seemed a little bit more general, so if we wanted to roll out the same technology to other applications in the future, it might be more natural to do that. And also, my understanding is in Solar it's quite expensive to update your indexes, and although we have a lot more reads than writes, we do have writes going on continually throughout the day, and we wanted to make sure that when a write comes in, that gets reflected in the reads, relatively soon. It's, we're eventually consistent, but eventually shouldn't be too long. Any other questions? Yeah.
No, so when you do an update, do you do another cutover where you run them in parallel again to make sure the update is still?
Usually not. We have a load test environment, so we'll do some amount of testing before we go live with a major change to the application. But for the most part, we don't continue with shadow mode at this point because it's mostly stable. The types of changes that we're making now versus a year ago are more minor. I imagine that we would go back to that if we were looking at something that was more significant architecturally.
Did you have to wait for a maintenance day where you pull it down for a couple hours or something?
The application keeps functioning, so we don't have any downtime from the outside. And that's why I was talking about doing a side load with a different database name, because we're able to serve traffic out of one database while we're populating another database. And so we really just have a blink where we switch over from one database to the next and then delete the old copy. Yeah?
At one point you mentioned that you're happy with the stability of it and the way it works and production and all that. I guess what I was just wondering was, to get to that point, was it really gnarly and treacherous and so on, or was it smooth sailing, the whole way to the point?
Somewhere in between. I would say we learned a lot, not just about the product and what it would and wouldn't do for us, but also just gained a lot of expertise in what the appropriate way to use it was as application developers, by having that shadow process and by measuring everything from the beginning. That really helped. I think if we had just dived right in at the beginning and said, MongoDB is great, we're going to have a new version of our application, it's all going to be MongoDB, and our cluster is great, and we want to go live next week, then probably it would have been more like the latter scenario that you outlined, with a lot of gnarly and a lot of gnashing of teeth, because we iterated on shard keys, for example, several times, and there were instances where we found out about a bug in the version of Mongo that we were using that may or may not have impacted our data. We didn't really have a good way to tell, so we wanted to be able to just reload stuff. So by taking an incremental approach and really being mindful of what we were doing at each step, we were able to kind of keep ourselves out of any situation where it was like, oh my goodness, something's going to be impacted in production now and we don't know what to do. But it did mean that we had to do a phased rollout over some months to do it that way. Yeah, question here.
Going through a Mongo upgrade from one release to another, and how do you transition in that way?
We have done minor version upgrades, or I guess you'd say patch version upgrades, since they haven't gone from 2 to 3 or whatnot. we have not done, since going to production, we have not done a more significant version upgrade. We've talked to the MongoDB folks about potentially doing that in the future, and I think we would just work with them closely and make sure that we were on top of all the best practices. But we have significant internal kind of knowledge base built up in terms of what process to use when doing an upgrade, because as we talked about, there's a lot of moving pieces. You have all the MongoD instances, the Mongo S instances. You have coupling maybe between the Mongo S instances and your application instances. So you really want to think about when you're doing an upgrade or preparing for an upgrade, just script it out ahead of time and say, I'm going to take this thing down, then I'm going to reboot this thing, then I'm going to bring it back up, then I'm going to apply this configuration. Whatever the order is for your configuration, just make sure that you understand it first. And if you have like a secondary Mongo test environment, maybe it's VMs or some old hardware boxes that you have lying around that you're not using for production anymore, try it out. Since you have that nice secondary copy of your data, refresh that into your test environment instead of your prod environment, and start knocking stuff over and bringing it back up again, and understanding how it happens, and practice taking stuff down and bringing it back up, deploying the new version and new configs. Yeah.
So, let me see if I understood what you said about your switching schemas.
Mm-hmm.
So you have collection A,
Mm-hmm.
and you're going to go to collection A prime. Is that collection sharded? And if so, are you switching all the shards at the same time?
Yeah, what we do is if we need to do a data reload, we do it at the granularity of the whole database. So what that means is, for example, the locking takes place at the level of a database, and you also need to specify at the database level to begin with, are you going to shard this database at all? So rather than trying to make these fine-grained changes and making sure we do them correctly, it's easier for us to just say we're going to refresh the whole data set. Depending on how big your data set is and how long you're prepared to wait for that to happen, you may want to take a more complex path or not. But for us, we found that the amount of time that it takes to sideload the subset of the data that we need to have in Mongo was acceptable. Yeah.
Since you have this architecture where you have a relational database sitting on top of Mongo database.
Or the other way, actually.
The other way around. So what's your disaster recovery process for that? Because it seems more complicated.
Well, first of all, we have a number of replicas within each shard of the Mongo database. So we could lose some number of machines without losing data, just at the Mongo level, without having to restore anything. Beyond that, we have DR. We have a certain set of plans at the relational level, for how we would restore Mongo if Mongo goes away, and then we have whatever plans at the relational level. So it's a tiered thing. Does that answer your question, or?
Well, I guess maybe I'm not understanding it. I see must be a tight correlation between the relational database and Mongo, and so if you have.
Well, there's eventual consistency between them. So if Mongo gets somehow disconnected from that source of truth for some time, then we would have.
All systems go down, and your particular site. So you have another site.
If the whole data center goes down because an earthquake opens up underneath it, that's.
So you have one data center?
I'm not going to get into number of data centers and DR at that level.
So you don't have
But
in Colorado
I'm not going to comment on number of data centers. But in terms of if every system on the site went down, that would be something beyond the scope of MongoDB in this application. Yeah.
Just a quick question on the side loading. When you increment the suffix and so on? I mean, how do you get the app to know to use the thing?
We have configuration files for the app that tell it what to look for, and so we just refresh those. But you could, pick your poison. You could have, a REST endpoint that you would hint that would push it in there, or, but yeah, it's an application level configuration. Other questions? All right. Thank you very much for coming, everyone.